Hi class, welcome to lesson 33 of Unit 5. In this lesson, we are going to look at how bonding in covalent compounds influences three-dimensional shape. You must be able to correctly illustrate the two-dimensional Lewis dot diagram of covalent compounds in order to predict their three-dimensional shape. In nature, three-dimensional shape is important because structure or shape determines function. We've already learned about polar bonds. Polar bonds exist when two atoms with different electronegativities are bonded. Now we're going to talk about polar molecules. Polar molecules are molecules that have an unequal distribution of charge. Polar molecules are important to recognize, as these forces that are between molecules influence the physical properties like melting point, boiling point, and solubility of different substances. The polarity of a molecule is determined by the symmetry of its Lewis structure. One of the most important properties determined by molecular polarity is solubility. In chemistry, we use a saying, we've already learned about polar bonds. Polar bonds exist when two atoms with different electronegativities are bonded. Now we're going to talk about polar molecules. Polar molecules are molecules that have an unequal distribution of charge. Polar molecules are important to recognize, as these forces that are between molecules influence the physical properties like melting point, boiling point, and solubility of different substances. The polarity of a molecule is determined by the symmetry of its Lewis structure. One of the most important properties determined by molecular polarity is solubility. In chemistry, we use a saying, like dissolves like. That means polar substances dissolve in other polar substances. Nonpolar substances dissolve in other nonpolar substances. And ionic substances, which are very polarized, dissolve in polar substances. This explains why oil doesn't dissolve in water, because water is polar and oil is nonpolar. Only like dissolves like. There are a couple ways to determine molecular polarity. First, draw the Lewis dot diagram of the entire molecule. Then you can count the number of bonding pairs and number of non-bonding pairs of electrons, and look for symmetry. You can use the abbreviation SNAP. Symmetric is nonpolar, and asymmetric is polar. Another general shortcut is that symmetric, the last subscript is even, while asymmetric, the last subscript is odd. Let's look at the following question. Here we're looking for a nonpolar molecule. Whenever you see nonpolar, you should think symmetric. You can see in the first formula, NH3, there is vertical symmetry, but not horizontal. So that is asymmetric. In hydrogen fluoride, again, we have asymmetry. In carbon tetrafluoride, we have symmetry on both the vertical and the horizontal. Make sure that you look on both the horizontal and vertical planes for symmetry. And lastly, water lacks symmetry on both the vertical and the horizontal as shown. Remember the shortcut. If you identify the last subscript, if the last subscript is even, it is nonpolar. If the last subscript is odd, it is polar. Remember that hydrogen fluoride and water both end in a subscript of 1. It is important to determine not only the polarity of a molecule, but also the shape of a molecule. Take a minute to study this chart, and then use this chart to answer the questions below. Let's review some Regents questions together before you answer the circled questions on your own. Carbon atoms in graphite and carbon atoms in diamond have different. So we know graphite, also known as pencil lead, is very different than a diamond. They're both made of carbon atoms. Since they have the same atoms, they cannot have different atomic numbers. But they must have different structural arrangements. Remember, different formulas means different names and different properties. The next question asks, how can you explain that extreme conditions of very low temperature and very high pressure are required to liquefy chlorine gas? Recall that gas particles are very spread out, while liquid particles are closer together. In order to make these particles get closer together, we have to add an intermolecular force of attraction. So we know that chlorine, being a gas, has no or very weak intermolecular forces of attraction. The next question asks us which requires valence electrons to be transferred. Recall that ionic compounds transfer valence electrons. This next question asks us to identify the substance that does not conduct electricity as a solid, but does conduct when melted. This is a property of an ionic compound. Ionic compounds in liquid and aqueous state have free-moving ions, allowing them to conduct electricity. Now let's look at the first question you'll have to answer. Which of these represents a nonpolar molecule? Remember that nonpolar means symmetric, or the last subscript is even. Can you find the nonpolar molecule? The next question are matching exercises. First, we're looking for a molecule with nonpolar covalent bonds. Remember that nonpolar bonds occur when the difference of electronegativity is 0. In the next question, we're looking for the match that has polar covalent bonds but a nonpolar molecule. Recall that polar covalent bonds exist between two different elements, but nonpolar molecules are molecules that are symmetric or end with even subscripts. In question number 8, we are looking for the dipole, the polar compound with a linear shape. That means we'll be looking for two different elements that are combined in a straight line. Question number 9 will not appear on the Regents. Question number 9 describes silicon carbide. In question 10, we are looking for an ionic compound. Remember that ionic compounds are between metals and nonmetals. Question number 11, you can refer to the chart about molecular shape. We're looking for a molecule. Remember, the word molecule means covalent, and covalent means two nonmetals, with a pyramidal shape. A pyramidal shape arises when there are 3 bonding groups and 1 non-bonding pair of electrons. Let's work on questions number 12 and 13 for review. Question number 12, we're looking for sodium sulfate. We want to find the symbols for both sodium and sulfate. Sodium's symbol is Na, and its charge is +1, Sodium is a metal, so it will form an ionic compound with sulfate. Sulfate is found on reference table E. Sulfate is a polyatomic ion with a charge of -2. In order to obtain a stable noble gas electron configuration, these two components must combine to have a total charge of 0. So our best choice is choice B. Lastly, we're asked to apply our knowledge of like dissolves like. We're looking for a low boiling point and insoluble in water. So recall that low boiling points represent covalent compounds, so it can't be ionic or metallic. Covalent compounds could be polar or nonpolar, but the rule is like dissolves like. Water is polar, so we are looking for another polar molecule. This concludes Lesson 8 of Unit 5. Make sure your notes are in order, as you will have an open note exit ticket soon. See you in class.